Hey guys, I hope you're doing well. Hope you had a great weekend. We're going to cover the final section to our solving equations unit, and that's going to be proportions, ratios and proportions. A ratio is two fractions that are equal to each other, and a proportion is going to be how we would use those. And we'll talk about a couple strategies and how we can go ahead and solve these equations. And then we're going to talk about examples of problems that you won't be able to consider a proportion and these methods won't work for. So let me go ahead and share screen here. This won't take too long for this particular lesson. It's pretty straightforward. So you'll see here I've got a handful of examples of ratios and proportions. I want to tell you right away that these problems are coming from your homework. So I'm going to work through a handful of these homework problems for you. So notice first of all, here you have your two fractions that are set equal to each other. Has to be a fraction on both sides of the problem. Now, if it's not a fraction, you can turn it into one. So if it's just 5, you can make that 5/1. So at any point in time, you can use this method if you like, just by creating fractions. Now, you can't have anything extra on a side of the equal sign. We'll talk about that. So the first two examples are going to be ratios and proportions that are pretty straightforward because the fractions are easily set up to be equivalent. And what I mean by that is if I look at what I'm searching for, I'm trying to find out what x is. Well, x is in a fraction that's over 4, and it's set equal to 3/2. Well, if we use equivalent fractions, and I look at this, it's pretty easy to figure out how 2 can become a 4. And I'm always going to work towards the variable that I'm solving for. I'm trying to find out what x is. So in order to make these fractions match, 2 times 2 gets me to 4. Well, if I do that to the top of this fraction and multiply that by 2 as well, because we need to maintain the top and the bottom as being equivalent, 3 times 2 means that x has to equal 6. And I've now solved for x. I'm done with that problem. So when we have fractions that are easily set up to be equivalent fractions, you can do that. Now, we've been doing that when we found common denominators. Right? The variable we're solving for can be on the bottom. I'm going to use the same basic principle here to solve for a. If I'm going to go towards the variable, I'm going to say, okay, 1 times 3 gets me to 3. And I'm going to have to do the same thing on the bottom of the fraction and multiply by 3. And 6 times 3 is 18, so therefore a equals 18. Now, this is a pretty basic way to find the missing variable when we're talking about proportions. But there's another method that we can always use, and that becomes really important for this third example. Because you'll notice in this third example, I cannot work from 4 to 3 easily. There isn't a simple multiplication or division that gets me there. So we have to have another method. Now, this method I'm going to show you on example 3, I could have done for 1 and 2 as well. But I wanted to show you that there's more than one way to solve these. We're going to use what we call cross products or cross multiplication. This only works when you have a fraction on both sides of the equals. If there's anything extra, then this method will not work. And remember what I said at the beginning. If you have a whole number or an integer, you could turn that into a fraction. So cross products says that I'm going to multiply across the equal sign and create kind of like a butterfly effect here. And what this says is I'm multiplying across the equals within that loop. So this becomes 4 times w equals, and on the other way, it's 3 times 5. So I'm multiplying across, and basically what we're doing is we're using the ideas of earlier in this unit to get rid of fractions. And that's essentially what's happening in this problem is we're working to get rid of fractions throughout the whole thing. And you'll notice the fractions are now gone. Well, 4 times w is 4w equals 3 times 5, which is 15. And I'm just solving an equation at this point, so I'll divide out the 4. And w equals 15/4. The answer is a fraction, which is why at the very beginning I couldn't use a shortcut like I did on 1 and 2. The shortcuts are going to give you answers that work out nicely for you. This cross products method is going to be even more important for these next two examples, because not only do I have a variable, but I have a variable that is involved in an expression. And on the final example, I have variables on both sides. And so solving for x becomes even more challenging. But if I use my cross products, I'm going to set it up here. Be very careful on this particular step. I'm going to show the work. I have 12 times x plus 1. And on the other side, I have 5 times 4. I want you to notice I put the x plus 1 in parentheses because 12 is being multiplied by all of that. That means distributive property. So I get 12x plus 12 equals 20. I'm going to subtract the 12 on both sides, and I get 12x equals 8. Divide out the 12. And when I reduce, 8 over 12 is going to reduce down to 2/3. We'll go ahead and put a circle around that answer up there. So what did I do here? I did my cross products, and I said 12 times x plus 1 and 5 times 4, and I wrote that over here. I made sure to use parentheses because I had to keep track of the fact that it was distributive property. And then at that point, I'm just solving a multi-step equation. So once I use my cross products, I have a multi-step equation that is everything like I've been doing the rest of the unit. This one here, I'm going to use the exact same method to start. I'm going to use cross products. I'm just going to have variables on both sides. So I have 3 times x minus 2 and x plus 5 times negative 4. So I'm going to set that up as 3 times x minus 2. So that's this loop here, equals, and on the other loop, it's going to be, and I'm going to write the negative 4 in front, negative 4 times x plus 5. So I set up my multiplication here. I use distributive property, and now it's just a multi-step equation. I get 3x minus 6 equals negative 4x minus 20. I'm going to move the 4x to the other side by adding it. 7x minus 6 equals negative 20. It's a two-step equation, so I will add 6 to both sides. 7x equals negative 14. Divide out the 7. X equals negative 2. So you have a multi-step equation with variables on both sides. Now, if this portion here is still something that you're struggling with, I would highly recommend you go back and watch one of the earlier YouTube lessons on solving multi-step equations. We have to have those skills in a really good place right now in order to do our proportions. I want to show you an example of something that will not work with this. And it is very tempting to do this when we have a particular problem, but you cannot do it with solving proportions. If I give you a problem that looks like this, x plus 3 over 4 equals, and let's just make something up here. That's a proportion. You can use your cross products. The moment I see this, you cannot use your cross products any longer. This is no longer a fraction equals a fraction. The plus 7 changes everything. Your only option at this point is to get rid of fractions, to do what we have done earlier in the year to get rid of fractions. Now, if I was to do that here, and I'm going to go ahead and show you this step because this is really important for solving these, I'm going to get my common denominator of 20. And then I'll have the plus 7 out here at the end. And I'm going to multiply everything to get rid of the 20. The reason why I wanted to show you this is because when I changed this denominator to 20, I got that by multiplying 4 times 5. Well, when I have x plus 3 on the top, and I multiply it by 5, let's just do this here. We're going to times it by 5 on the bottom. I have to do that to the top as well. So this becomes 5x plus 15. I have to make sure that because I multiplied 4 times 5, I have to do all of the top as well. And so it becomes something that's larger because of distributive property. So if I do 5 times 4, to get to 20, and I do that to the top, this is going to become 4x minus 8. And then I'll times everything by 20 over 1. And I don't need to finish that at this point because you've seen examples of that. But I wanted to show you what happens when we're thinking about using cross products and it does not work. Okay, so a quick little review there of getting rid of fractions. And then obviously we've got our problems for cross products and solving proportions. Okay. Hope that's going to help you guys out a little bit. I would recommend practicing some of those problems and then seeing how it goes. Go ahead and stop sharing here. Your homework is going to be solving ratios and proportions, worksheet 4-1, and then there's a textbook page that goes along with that, and you'll have 2 days to work on it. Have a great day, guys.